two large conducting plates parallel to each other with a separation of 2 cm between them. An electron starts from rest near one of the plate and reaches the other plate in 2 microseconds. Find the surface charge density on the inner surface. Fine. Let's say I do have two surfaces like this. Let's say the charge density will be sigma and minus sigma. An electron starts from one of the plate, and of course it would be negative plate, so that it can reach easily the another plate, and it reaches the another plate in 2 microsecond. The distance d is 2 centimeter. Let's say t is 2 microseconds. Fine. So first of all, I'll use the equation S is equals to ut plus half at square, so as to calculate the acceleration of the electron. So initial velocity is of course 0, as it starts from rest. The S is equals to d half of a t square. The t is the time taken to reach the another plate, so acceleration comes out as 2d by t square. Let it be equation number 1. Now second point is that we know that electric field due to a large conducting plate is given by sigma by 2 epsilon naught. Now I do have two plates over here. Now please note that the direction of electric field due to the plate A is in this direction with a magnitude of sigma by 2 epsilon naught, and the direction of the electric field due to the minus sigma charge is also sigma by 2 epsilon naught, and that too in the same direction because the charge is negative. So the net electric field in this very direction is given by sigma by 2 epsilon naught plus sigma by 2 epsilon naught. That comes out to be sigma by epsilon naught. Fine. This is the electric field existing between the two plates, and since if this is the electric field, then a force will act on the electron that will be equal to QE. This force will be equal to mass into acceleration, so that I can get the value of acceleration. Now we know that acceleration is given by 2d by t square. So the substitute over here, the electric field is sigma by epsilon naught, mass into 2d by t square. I had to calculate the surface charge density, that is the value of sigma. I know the value of rest of the variables, so sigma comes out to be m into 2d by t square into 2 times of epsilon naught by q. So just substitute the values. M is the mass of electron, 2 times of d is 2 centimeter or 0.02 meter, divided by t square, that is 2 into 10 to the power minus 6 whole square, into 2 times of epsilon divided by q, that is the charge of electron. So on solving this equation, I get the value of sigma as 7.5 into 10 to the power minus 7 coulomb per meter square.